Metzger, welcome to the third video in the first module where we started to count down the top 10 questions that students missed on that first Gen Chem exam. And you know that the number 10 in the countdown was isotopes. And so the first video we looked at the question that they missed as well as the root cause of why they couldn't figure it out. And then the second video we went into the training. Now let's look at similar types of questions so that you are familiar with the concept and how it may look on a exam for you, okay? So here's an example pulled from my archive of exam ones that cover the topic of isotopes. And this question, which two of the isotopes listed below have the same number of neutrons? And so then you've got two sulfur, chlorine, and argon. Now the question here is, it's not necessarily finding which one of these isotopes. They all are isotopes. What you need to do is you need to know how many neutrons each of these have and then basically find the pair that have the same number of neutrons. So in this case you want to go back to the training video number 2 where we looked and created a table, and you can then determine based here that you have 16, 16, and 17, and 18 protons, and then you can then look at the mass and then do a subtraction and find the number of neutrons. So quickly you can do the math. This has 16, and here this has 18. This is at 20, and if we take a look at this, 34 minus 12, we're at 18. So we have we have our two choices here. So it's sulfur and chlorine. Just looking at the mass and the proton, you can do that quick arithmetic and figure it out. So in this case it's going to be answer number B, not B, letter B. Alright, let's move on. Again, here's another example. How many protons, neutrons, and electrons is in oxygen? 18. So you are given the mass of 18, and then you have to determine oxygen, which is going to have 8 protons. And so you can quickly do quick math and go 18 minus 8, so you have 10 neutrons. So you can make sure that you select the right one, which in this case we know that electrons and protons are going to be the same, so 8 protons, 8 electrons, and then we just did the math, 18 minus 8, and we got 10 neutrons. So the choice here is D. And you can do that same exercise, very similar with the bromine. Do that table, determine, you can look at the bromine table and you can find that it's going to have 35 protons. So then you can do a mass of 81 minus 35, and then you can determine how many neutrons. And given this question, this also has a very fast elimination. You are given the mass of 81. So anytime that the mass shows 46, 35, or in this case 116, you can eliminate those choices right away. So it's really going to come down to A and D, and then based on what's 81 minus the 35, you can then figure out how many neutrons. And there you go, you'll have the correct answer. Same exercise here, so you can look. If you know the skill and the ability to tabulate how many protons, how many electrons, and how many neutrons the atom has, then you can figure out these type of questions. I threw this one in because this is a fundamental, I think, skill even beyond isotopes. In this case, this question says a mystery atom has a mass number 26, atomic number 12. The atom has a net charge of +2. How many electrons does this atom contain? So in this case, you've given the mass and you've given the atomic number. So you know that it has 12 protons, and then if you do 26 minus 12, you can figure out how many neutrons. But that's really almost a red herring. What you need to figure out is, for an atom to have a net charge of +2, it means that it has 2 less electrons than protons. So in this case, if the atomic number is 12, it means that the number of electrons has to be 10. So this information here might be more what we call a distractor, because you just have to know how many electrons you have. And here is the next level, and I threw this in because we'll go into this in another module, but now that you understand the idea of isotopes and how it's different mass and different protons, different electrons, you then can start to determine the rate of existence of these different isotopes. But that's for another topic. Again, this is Brian Metzger with Module 1. Thanks very much for watching. Bye.